In this video, we're gonna focus on exam possible questions on electrostatics force. Let's solve this question here. Let's write 2-point charges are separated by a distance d and feel a force F. Full stop there. What would the force be if the two charges are moved a distance d over 3 apart? Okay, now let's solve this here. Solution, please. All right, now we are given 2-point charges, 2-point charges. Okay, now that is q1. Okay, we are taking q1 to be equal to plus q, and then q2 to be equal to um plus small letter q. Please take note. Now, but if the 2-point charges are attractive, it means that one is going to be plus q and the other is going to be negative small letter q. Please take note of this. If the 2-point charges are attractive, it means that one will be plus q, the other will be minus q. Okay, but since they did not mention attractive force here, it means that this is plus q, this is plus q. Okay, so the 2-point charges here, that is these two guys here, q1, that is this here, plus q, and this here minus q, sorry, plus small letter q here. They are separated by a distance. So these two guys here are separated by a distance, and the distance here is d for this. So to calculate the force here between them, let's calculate the force between them first. Calculate the force between them here. We say that whenever you are asked to calculate force between two charges, we apply Coulomb's law. So this is going to be F, applying Coulomb's law, is equal to K Q1 Q2 over R square. So let's replace what is given to us, K. Now Q1 is capital letter Q, and Q2 is small letter q over d square. Okay, now this is the first statement, and the first statement here is giving us equation 1. Please take note of this. So let's interpret the second statement. The second statement here, they said what would be the force if what would the force be if the two charges are moved a distance d over 3 apart. Okay, now the same two charges here, that is from this sketch here, this is plus capital letter q, this is plus small letter q, is separated by a distance, and that distance is d over 3. So from this explanation here, from this sketch here, we have to calculate the force again from this second sketch. So our F will be equal to plus K Q1 Q2 over R square. So let's replace here. This will be K. Q1 is Q, capital letter Q. Q2 is small letter q, over the distance here is d over 3 or square. Please take note. Now we have to evaluate the second force to get the clear expression. Okay, let's evaluate the second force here. All right, let's evaluate the second force here. The second force here, F, is equal to K Q, small letter q, over if you look into this, we have this to be d over 3 all square, meaning that the d is being affected by this 2, by this square, sorry for that, and then 3 is being affected by this square also. So d all square will give us d square, so this will give us d square. 3 all square will give us 9. All right, evaluating this here, this guy here is separated from this d over d square over 9. So if that is so here, this is going to be k capital letter Q small letter q divide by d square over 9. When you apply board mass here, our f here will be equal to plus k q small letter q times, when you multiply here, the denominator by your right will move to the numerator, and the numerator by your right will move to the denominator. So this will be 9 over d square. So I will have this to be plus 9 kq capital letter q times small letter q over d square. So our second force here is equal to 9k capital letter q small letter q over d square. This will give us equation 2. So we have gotten equation 1 from the statement, and we have gotten equation 2 from the statement. So let's compare the equation 1 from the statement and equation 2 from the statement, and later unite them together to have a single force. Okay, now this is force, that is the first expression from this first statement. That is we have this to be k q capital letter q small letter q here over d square. All right, this is our equation 1. Now the next one here, f is equal to 9k capital letter q small letter q over d square. This is our second equation. So let's unite this together. Now listen to me carefully. Equation 1 and equation 2 is almost the same. Okay, so it means that wherever you see k capital letter q small letter q over d square, you replace that as f. So if you look into this here, from here, from this here, we are having this to be kq small letter q over d square. So from here, we have this to be f. So replace this here. It means that imputing equation 1 into equation 2, that is imputing equation 1 into equation 2, that is this. Okay, when you do that, this is going to be f is equal to 9f. So the answer to this question here is this. Okay, so let's check the option here. Is it option A? Is it option B? Is it option C? Okay, so the right option here is option D. Okay, our next topic here in this series is going to be electric field.